Hey guys, my name is Tu. In this video, I'll be demonstrating on how to perform a restart analysis in NX. Basically, restart analysis is part of the CAE application. There are many purposes to perform a restart analysis. In this example, I will show you how to perform a restart to add additional loading condition to an existing fully defined simulation model. So let's begin by opening one part file. So let's double click this file. So what I have here is a CAD model of a bracket. So this bracket is have a shape of a L shape with two holes. So let's proceed to the CAE application. So File, Advanced Simulation. Okay, let's create new FEM and simulation. Okay, make sure the solver is NXCAE, analysis type structural. Okay. And I'll just leave the solutions as default. Okay. Now we can proceed to create the tetrahedral mesh. And the element size is 5 mm. Okay. Okay, my mesh is ready. I can proceed to assign the material. For example, steel. Okay. So the material is steel. And the name for this property is steel, the property of the mesh. I can assign a different color. Let's say this color to the mesh. Now that the next thing I can do is to define the constraint and the boundary, the loading condition for this mesh. For example, I can proceed to the simulation file, make work file, and go to constraint type, fix constraint. I will fix the whole position. Okay, and I will assign a weight on top of this bracket. On this surface, the weight, for example, is 10 kg, or 10 multiplied with the gravity 9.81. Specifying the vector is pointing downwards, and OK. So now this is the analysis is fully defined with all the necessary entities. For example, the mesh, the material, the boundary conditions, and the loading conditions. So this analysis setup is already complete. However, if you would like to perform a restart, or you anticipate a restart analysis might be necessary in the future, you can always define another parameters. For example, you can go to the solution one, edit solver parameters. Scratch, you will need to choose no. So scratch means when scratch is equals to yes, that means whenever the calculation of the analysis is completed, the solver will automatically delete the scratch files. So if I choose no, that means the scratch file will be maintained for the restart application. Okay. And the next thing, you can go to just solve it, and you choose solve. Okay. So now that the analysis is completed, we can see that these are our files at our directory. The .dat file is the input file. the .dball and the .master file are the temporary scratch file. So you can see that the temporary scratch file usually has a very big size. Okay. Now we can just quickly have a glance at the results. So these are our results: displacement results, the stress result, and so on. So let's say you would like to perform a restart analysis by defining another loading condition. For example, the current loading condition is pointing downwards. The vector is pointing downwards, but for this time you would like to restart that allows a loading condition that points to the x-axis. So let's return to the simulation navigator. Please bear in mind that a restart analysis is kind of like advanced stuff in a CAE application where the user will need to have some basic experience in reading the solver keywords. When it comes to restart analysis, we will need to do some keyword editing using word processing programs such as Notepad or other free software such as Notepad++. The way that I'm showing you or demonstrating to you here by far is the simplest way to do a restart analysis with the least manual editing work. So starting from here, you just right click on solution 1, go to select new subcase. Okay, for this subcase, we'll define a new loading condition. So return to the model and create for another load at this surface 10 multiply 9.81 at the x-axis in that direction. Okay, so notice that on subcase number 1 the force is pointing downward, and subcase number 2 the force is along the x-axis. So now the restart, how do we get the restart results? We can just right click here and go to solve. Everything seems normal, but at here, submit, you have to be careful here. You need to choose write solver input file only. Okay, and notice that this file is modified. So I'll just quickly let you have a glance at it. So this file will contain subcase number 1 and subcase number 2. So the .dat file is always the input file for Nastran solver. The input file actually is a list of wordings, logical terms and keywords that defines the simulation model. For example, in this input file, the default units is given here, and these are the outputs. These are the subcases for this input file. We need to modify this input file into a restart input file. So to do that, we can just change the structure here. So from here, I'll just at the top of the line, so you see that for each line there is a $sign here. This $sign will actually is just for comments purposes. So for example, this is a comment about this input file is created by this translator, and so on. So this comments line will not be solved by the solver. So we can just start from here, press enter to enter a new line. So for this new line, I will say restart. And the second line, I'll type assign so this is the name of the master file. So always check back your directory, and this is the file that you should be pointing to. So you can just copy this. Oops. Copy. So paste dot master. Okay. Now for this will define that this input file is a restart input file based on the master file as such. For this restart, I will only want to run subcase number 2, because subcase number 1 I already run it. So I can just remove subcase 1 here, just from this command until subcase 1 and the label is removed. So I'll press delete and put back a $sign here. I will just keep the output as the same for subcase number 2. So this load 2 is this load 2 belongs to subcase number 1. The subcase number 1 contains load ID number 2. So I'll need to delete this one as well. Put a $sign here. Now let's go here. Subcase number 2 with the label subcase static load 2. So check the label, static load 2. Okay. Contains a load ID of number 3. So load ID number 3 refer to force 2. But for those of us that are not so familiar with the keywords, we can just leave it as it is. So the next important thing that you would like to check is begin bulk. So beginning from this line, it will show, from this line onwards, it will show the simulation model. For example, the parameter of the simulation model, the grid point, meaning the nodes of the simulation model, the elements, and so on. For this begin bulk, we will need to delete everything except for load ID 3, which is for the subcase. So for restart analysis, bear in mind that we only keep those that are different from the original analysis. So these quantities these parameters belongs to the original analysis. So we no need to give this information again, because all this original information already contains in the Scratch file. It's already computed in the Scratch file. So all this information can be deleted. So we'll just go on and delete all this information. The grid, the C tetra, these are the keywords for the tetra elements. So here, SPC is for the the boundary condition, the fixed constraints. So it's governed by the SPC keyword. This as well, we need to delete it because it already is contained in the original analysis. So force number 2 is not needed for the restart analysis as well. So force number 2, you can see that the name for force number 2 is force 1. This is not relevant for the restart analysis. So we'll just somewhere here. Okay, press the delete button to delete it. Okay, put a $sign back. So I only have a false. So just verify I only have a false input. Okay, that's the end of the file, input file. So now let us just save this file and name it a different one. Restart, for example. Restart 1. We can save it as a txt, no problem. Save and close. Now back to the analysis. We can just create another analysis. Right click on the sim, new solution. So I'll just name this one number 2. Okay, so the number 2 solution does not have any constraint defined yet and does not have any loads. However, we can just use this one as an empty space to contain the restart results and the calculation. So the way to do it, we can just right click here and choose solve directly. But here we need to uncheck this model setup check, and we'll choose run, edit, and solve input file. Okay. So I'll just maximize what this input file contains. So let's have a glance. So this input file already contains output options and some of the parameters and also the mesh. So these grids are from the mesh. So the mesh and the elements. These are the elements. Okay. However, this input file does not contain any boundary conditions, does not contain any loading conditions. So these are the materials information. These are the properties of the mesh, but it does not have any loading and boundary conditions, which is normal. Anyway, we are not going to use all of this information at all. So we can just right click, select everything, all, and press the delete button. Because we are not going to use all this information at all, but we are going to copy the information that we have created for the restart analysis previously. Copy everything, select all, copy and paste. Close the restart, and this you need to save it and close again. So that means once I press the close button, the analysis will solve based on the information given in restart 1. So it will actually use the scratch file, the master file, the debug file to solve for the subcase number 2 in the first solution. So I'll just click save and click close. Okay, so it seems that the solution is already done. You can just double click the results, and here we quickly do a comparison side by side. The displacement results for first solutions, first subcase, and the second subcase. This will synchronize the view, and we can briefly have a glance at the deformation shape. So this is the first subcase, this is the second subcase. So what is the benefit of performing a restart analysis here? So this is a very significant point that I will point out for you. So let's try to open the log file for the first run, the cold start run. So we just double click this file, the log file, and drag it to the bottom. And notice that this line here showing that this analysis, the cold start analysis, took 40 seconds to solve and complete. 40 seconds. And whereas for the restart analysis, let us just try to open the subcase number 2, the log file. Here, open. For the second subcase, it took me 6 seconds. So this is a significant benefit that the time has been reduced drastically. So this is one of the benefits for performing a restart analysis that will help you to save time. So that's it for this video. I hope you enjoy it. For further questions or inquiries, please leave a comment at bottom here. Thank you.